Alright, today we're talking about 433 multiplying polynomials. This is the last bit of instruction on Unit 4. This finishes us out on the standard that deals with adding, subtracting, and multiplying polynomials. Next year you'll divide polynomials, either through long division or synthetic. But this year all we have to do is talk about add, subtract, and multiply. I've got some things over here that may be a little unusual for you, but what I'm trying to show you is all the things that we potentially might be asked to multiply. Okay, at the top you see monomial times monomial. Here we move to monomial times binomial, and then monomial times trinomial. Okay, that's it on a monomial. Somebody asked earlier if you would ever do a monomial times a polynomial, and you could. It's just the same process, so I'm not going to put it up there. Then we move into binomial times binomial, and then bi times tri, and then tri times tri. Okay? This is as far as I would ask you to do is a tri times tri. Okay? There's a lot of steps involved in that, a lot of room for error. But if you can do a tri times tri successfully, then you should be in good shape. Yesterday we reviewed some of the rules on exponents, so you should be good, but let's practice this first one here and kind of go through the progression and make sure that you're good. Alright, 4x squared times 3x cubed. Right? You have to know what to multiply and what to add. This is a monomial times a monomial. We're multiplying. We're going to multiply the coefficients. Right? 4 times 3 is 12. And x squared times x cubed is x to the fifth. How did you know fifth instead of sixth? What's your rule that we went over yesterday? When what? When do you add exponents? When multiplying like bases, what I had you write down that should be in your notes, when multiplying like bases, you add the exponents. And that comes second nature to me and some of you. But others of you may need to review that, because if you put x to the 6 right here and you multiply 2 and 3, you're going to miss every one of these problems. Okay? You have to know what to do there. Alright, let's do one more. Monomial times monomial, negative 3x times 2, well, let's stay away from that, 5x squared. Just monomial times monomial, you have to know what to multiply and what to add. Evans, what do you think the answer is? Put you on the spot, on camera. Negative 15x cubed. Outstanding. Good answer. Questions? You can say x to the third or x cubed, either way. Any questions on monomial times monomial? Alright, so let's move on. Right, we've got this one talked about. Let's move on to monomial times binomial. 2x times 4x minus 7 is a typical example. Okay, we can certainly make this harder or more difficult. What's one way that we could increase the difficulty of the problem? Bigger numbers, right, would be one way. What would be another way? Larger exponents would be another way. What's another way? More numbers moves into rigor. Right, as we increase here, we're increasing rigor. Difficulty, I could throw in a fraction. Right, we could throw in more variables. The 7 could have a variable on it, the negative 7. So there's different ways of adding complexity to the problem. Okay, all I have to do if I want to increase the difficulty is put a fraction in there. But the process is the same. When we see parentheses right here, what are we thinking to do with this 2x? Distribute. Very good. Good math word, right? We're going to distribute here and here. I want you to draw those arrows until you get more comfortable with this. Draw those arrows so that you know where that 2x is going. The biggest reason, or the number one reason that students miss these problems is that they don't distribute all the way throughout. They do here, and then they forget to do here. 2x times 4x is how much? 8x squared. 8x squared, right? 2x times negative 7 is how much? Negative 14x. Nothing difficult about that. Okay, if you know your multiplication tables, then there's nothing difficult about that at all. Okay, questions? Can we combine 8x squared and negative 14x. Can we combine these two? I didn't hear, boy, that wasn't a resounding answer. Can we combine these two things? No. No, why not? They're not like terms. They don't have the same base. They have both of them are x's, but x squared and x to the first power are not like terms. We cannot combine them. So what we just got done doing Monday and Tuesday was adding and subtracting polynomials, i.e. like terms. These are not like. Okay? Questions? Everybody got this? All right, I think we're good there. Let's talk about monomial times trinomial. Negative 3x squared, a little harder, right? I threw a negative in there, I threw a higher power in there, or degree. And let's do x squared minus 6x plus 9. Right, a little larger numbers, a little more difficult. What's the name of the game, though? What's your procedure going to be? When you see those parentheses, what are you thinking? How many times? 3 times. Try this one on your own. Try this one now at your desk. The name of the game is to distribute correctly 3 times. Alright, here we go. I distribute negative 3x squared onto x squared. What do I get?
Negative 3x to the 4th.
Outstanding. Okay, add your exponents. Negative 3x to negative 6x. What does that make? Positive, right? Negative times negative is a positive. Positive 18x what? Cubed. Very good. How about negative 3x squared times positive 9? What's that going to be?
Negative 27x squared.
Negative 27x squared. Good. Is this in standard form?
Yes.
How do we know?
Because the exponents are going down as you go.
All right, math word starts with a D. We want to use the right word. What do we say? The exponents are descending, right? X to the 4th, x cubed, x squared, they're descending. Okay? Do you have to be able to multiply? I should have done my arrow. Do you have to be able to multiply in order to multiply polynomials? Yes. If you're sitting there going 9, 18, 27 and counting up, right, then your multiplication skills are not as good as they should be. Okay? And it's just going to burn up some time. Any questions on monomials? Monomial times monomial, monomial times binomial, monomial times trinomial. It's all the same procedure. The first and only step really is to do what? Distribute. Distribute, distribute, distribute. In this case, we distribute 3 times. All right, questions before I erase? All right, so what are we fixing to do now? What are we fixing to do now? What's the next one? By times by. That's just a short way of saying it. By times by. Anybody know the FOIL method? Anybody learn the FOIL method last year in middle school? FOIL method. Good. That's a good thing. I don't teach the FOIL method. Okay, I had a student in first block know what it was. He went to middle school in Miami. So I'm not reprogramming some of you. You're getting it for the first time. And the reason why, I'll explain in a minute, is because all 3 of these are the same. Right? The method that I'm fixing to teach you works for this one, and this one. All right, so here's your basic by times by problem. I couldn't make it any easier. X plus 2 times x plus 3. Oh, did I say it wrong? X plus 2, x minus 3. Thank you. All right, so your first step is to distribute. Write it on the side over there, distribute. And then your second step is to simplify or combine like terms. You have an extra step in most of these where you have to be looking to combine like terms. All right, everybody watch me do the first one. Everybody's eyes up here watching me do the first one. Right? Have I been doing this a long time? Right? Do you trust me?
Yes.
Okay, am I going to show you the easiest way to do it?
Yes.
All right, so watch. X times x is x squared. X times negative 3 is negative 3x. All right, that's the first one. I did it 2 times. Then I do the 2. 2 times x is positive 2x, and 2 times negative 3 is negative 6. Right? I did the x 2 times, I did the 2 times. Then I have to look and see, possibly, not always, but most of the time, if I can combine like terms. What is negative 3x plus 2x? Negative x. Didn't we spend all Monday and Tuesday doing that? Combining like terms? So you should be a guru at combining like terms. Your answer is x squared minus x minus 6. Right? By times by. What was our outcome? A trinomial. Our outcome was a trinomial. Sometimes it'll be a trinomial, sometimes it'll be a binomial. Could it possibly be a polynomial? Yeah, it could be. I'll show you an example in a second. Copy this down. Questions? All right, recap. What did we do? We took the x and we multiplied it here. We wrote it right here. We took the x, we multiplied it right here, and we wrote it right here. Then we do the 2. We do 2 times x and we write it right here. 2 times negative 3 and we wrote it right here. We use the distributive method to distribute 4 total times. 1, 2, 3, 4. Then we combine like terms and put it in the middle. Is my answer in standard form?
Yes.
Yes, it is. Okay? Questions? Any questions? All right, I want you to try this one. A plus b times a minus b. A plus b times a minus b. Is that by times by? Yeah, it's just variables though. Right? You have to know what to do. You have to know your rules of exponents. Try this one now at your desk. All right, because this one's a little different, normally I'd have somebody come up and do it, but because this one's a little different, I'm going to do it for you. A times A is what? A squared. A times negative B. Negative AB. You could put BA, but it's just easier to leave it in alphabetical order. Okay, that's your first step. Distribute the A. Then we distribute positive B 2 times. What's B times A? It'd be positive AB. Now I could put BA. Multiplication is commutative, right? 2 times 3 is 6, same as 3 times 2 is 6. Why am I specifically doing AB and AB on both of those? To recognize that they're what? Like terms. That's going to help me out in the next step if I say AB and AB. Okay? All right, finish it out. What's positive B times negative B? Negative B squared. What happens to my inside terms? What's negative AB times positive AB?
Cancel out.
They cancel out. My answer is?
A squared minus B squared.
So we multiplied a by times a by, and our outcome was? Binomial. Okay, so it won't always be a trinomial. Sometimes it'll be a binomial. What method are we using? The distributive method. We're not using the FOIL method. Okay, if you go to church and get tutored by somebody, they might say, why are you foiling? Why aren't you foiling? And you say, because Coach Collins is showing us the distributive method. Okay? All right, we'll do one more. Any questions on this one? I'll leave it up. Any questions? Raise your hand. Why are you laughing? You don't get tutoring at church? Doesn't Miss Spillman's new name is Miss Winsky, I think. Doesn't she do some tutoring at church, son? Maybe not. Okay. X, let's say 2x plus 7 and then 3x minus 8. You can do this one, by times by, you're in good shape. Try this one now at your desk. What method are we using? Distributive method. How many times do you have to distribute? 4 times total.
So is like the full method bad or something?
No, it's just different. It's the same thing, really. And you'll understand why I'm teaching you this method instead of the full method in just a second. I promise. I asked you if you trusted me. Everybody nodded their head. Yes, yes, I trust you. Do I have a volunteer? It's called picking a non-volunteer. Watch and see if she made a mistake.
Isn't the full the front, outside, and yeah, I think we did.
First, outside, inside, last. Some people say front, outer, inner, last. I mean, there's different words for it. But
Yeah,
it's
we did that.
okay. You just didn't remember it. It's the same thing. Because aren't we multiplying the first? Aren't we doing the outside? Aren't we doing the inside and the last? It's just, it's easier when I do the next one on my list right there. You'll understand why. All right, how'd she do? 6x squared minus, or plus 5x minus 56. Is that the right answer? All right, what's one little mistake in multiplication going to do?
Make it wrong.
Right, what's one mistake in adding your like terms? Right, what if she put negative 5x? Would she get it right?
No.
No. So it's attention to detail in these problems that causes you to get the right answer. Right? You have to be methodical and be very meticulous and careful when you're doing the problem. Okay? Questions? Any questions? All right, I think we're good on by times by. I want to move to by times try. Everybody give her a hand for doing that one so good. All right, so here we go. X plus 2. I'm doing nice small numbers. X squared minus 3x minus 5. Now we have a by times try. Do you trust me? Have I been doing this a long time? Watch me do this first one now. Okay, watch me and how I do it so that you can do the same thing down the road. Okay, everybody's eyes up here. Watch me do this first one. What's the name of the game? We see parentheses, we see by times try, right? What are we thinking? 2 steps. Distribute and then what? Combine like terms. Everybody's eyes up here. Everybody's eyes up here. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 5 is negative 5x. Basically, the degree went up by 1 on each one of those terms. It just rose the degree by 1. All right, nothing new about that. Copy that down. Copy that down, and then I'll do step 2. Next Wednesday. All right, here we go. This is the shortcut. Then we do 2 times x squared. We start distributing the 2. 2 times x squared, but look where I put it. Why would I put it underneath there?
Oh, so we don't have to do so long.
So it's not all one long line, but what else am I doing? I'm stacking, to use that term, I'm stacking my like terms. Now I've got x squared over x squared. That's going to make the combining of my like terms easier. Alright, so let's do another one. What is 2 times negative 3x? Negative 6x. Where'd I put it? Right under the negative 5x, right? These are like terms and these are like terms. Alright, how about 2 times negative 5? Negative 10 goes right there. I draw my line and I combine like terms. We're doing a binomial times a trinomial. We're using the distributive method. We distributed x 3 times, we distribute 2 3 times. Okay? The last and most important step is to combine like terms. Do I have anything to combine with x cubed? No. No, so it just drops down. That's part of the answer. Can I combine my x squareds? What's negative 3x squared and positive 2x squared? What's that give me? It gives me negative x squared. Would I mark it wrong if you put a 1 right there? No, I wouldn't. Do you need to put a 1 right there?
No.
No. Why?
There's
Understood. Right? So we're done with these. All right, how about negative 5x and negative 6x? What's that give you? Negative 11x, so we're done with these. And then negative 10 just drops down. We did a binomial times a trinomial, and what was my outcome? A polynomial, right? 4 terms is a polynomial. We did terminology on Monday. Okay? Questions? Do you think you could do a bi times tri? Yeah. Is there a lot of room to make a mistake? Yes. In your job, out in your life, are you going to multiply polynomials on a daily basis? Probably. Probably not. Right? You may, if you have a job in a technical area, but probably not. Are you going to have to do a process that involves you doing 5, 6, 7, 8 steps correctly in a row without making a mistake? Yes. If you make lots of mistakes, are you going to be able to stay in your job? No. So look at this as being mental exercise, right? No, you're probably not going to multiply polynomials later on in life, but you're going to need it on next week's test, right? Look at this as mental exercise. Is there any penalty for getting this next problem that I put on the board wrong? No. It's a chance for you to get better. Be methodical, right? Be careful. Eliminate careless errors. Okay? This is mental exercise. We're trying to get smarter and better at doing a big process without making a mistake. All right, here's your example. X minus 4 times x squared minus 8x plus 11. Little bigger numbers. Little bigger numbers for us. We should be able to handle it though. Try this one now at your desk. All right, do I have a volunteer? Anybody volunteer to do a bi times try? Justin White, you want to come? Durden, you want to defer to Durden?
I mean, she had her hand up.
Okay, all right. Come on, Durden. It's okay if you make a mistake, right? This is where we get better. Outstanding. Give her a hand. Okay. Good job. Give me a thumbs up right here if you got it right. Right here at your chest, give me a thumbs up if you got that right. Okay? I say again, how could I increase the rigor? Oh, sorry, not the rigor. The rigor would be moving to try times try. How could I increase the difficulty?
A fraction.
What if I put a y right there? Would that change the problem? Yeah. What if I made this x squared? Would that change the problem? Yeah. Would that make it more difficult? Yeah. What if this was a fraction, like 2/5, and this was 3/4? Right? That would change it. But the process would be the same. Distribute, and then what? Combine like terms. Okay? Combine like terms. I'm going to stop the video here, and then I'm going to put a